Hello, everyone, and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. Thanks for joining us this Tuesday, January 14th, 2026. We've got a fantastic lineup of space news for you today.
We really do. We're covering everything from nuclear reactors on the moon to ancient Martian oceans, plus some fascinating discoveries about how spaceflight affects astronaut brains.
And we'll be talking about a major ISS update, a new privately funded space telescope, and scientists finally solving a 6-decade-old mystery about the moon's two faces.
It's going to be an exciting episode, so let's dive right in.
Anna, let's start with some big news from NASA and the Department of Energy. The United States is getting serious about putting a nuclear reactor on the moon by 2030.
That's right, Avery. This isn't just talk anymore. Last week, NASA Administrator Jared Isaacman and U.S. Secretary of Energy Chris Wright signed a memorandum of understanding that reaffirms their commitment to meet that ambitious deadline.
And this comes on the heels of President Trump's executive order from December calling for construction to begin on a lunar base by 2030, with a nuclear reactor ready to launch by that same year.
Isaacman said something really interesting in the announcement. He said, achieving this future requires harnessing nuclear power. This agreement enables closer collaboration between NASA and the Department of Energy to deliver the capabilities necessary to usher in the golden age of space exploration and discovery.
It makes sense when you think about it. Nuclear power can generate electricity continuously for years without refueling. And it's not affected by the moon's 2-week-long nights or changing weather conditions like solar panels would be.
And this isn't the first time NASA and the Department of Energy have worked together on space nuclear systems. They've been collaborating for more than half a century.
Right. Many of NASA's deep space robotic explorers have used radioisotope thermal electric generators, or RTGs, as a power source. We're talking about missions like the Cassini-Saturn orbiter and the Curiosity and Perseverance Mars rovers.
But this lunar reactor would be something different entirely. It would be designed to power one or more bases on the lunar surface as part of NASA's Artemis program.
Secretary Wright made a connection to America's historic achievements. He said, history shows that when American science and innovation come together, from the Manhattan Project to the Apollo mission, our nation leads the world to reach new frontiers once thought impossible. This agreement continues that legacy.
For NASA's Artemis program, having a reliable long-term power source on the moon is absolutely critical. If we're going to establish a permanent presence there and use it as a stepping stone to Mars, we need infrastructure that can operate reliably for years.
And the 2030 timeline is really aggressive. We're talking about just over 4 years from now. That's incredibly fast for a project of this magnitude.
It is. But with the renewed focus on lunar exploration and the competition with other spacefaring nations, particularly China, there's definitely motivation to move quickly.
Speaking of space developments, we have an important update on the Crew 11 situation at the International Space Station. Mission managers have officially given the go for the crew's return to Earth tomorrow.
That's right. NASA astronauts Zena Cardman and Mike Finke, along with JAXA astronaut Kimiya Yu and Roscosmos cosmonaut Oleg Platonov, are scheduled to undock from the Harmony module at 5:05 p.m. Eastern Time on Wednesday.
And they're coming home aboard the SpaceX Dragon crew spacecraft, with Cardman commanding and Finke piloting. The weather forecast is looking excellent for their parachute-assisted splashdown off the coast of California, which is scheduled for 3:41 a.m. on Thursday.
Yesterday, the crew spent most of their time preparing for departure. They packed cargo, reviewed return-to-Earth procedures, and transferred hardware. Cardman and her crewmates also trained on how to use respirators during unlikely emergency events, like an ammonia leak.
NASA is planning extensive coverage of the event. NASA Plus will begin live coverage at 3 p.m. on Wednesday when the crew enters the Dragon spacecraft and says goodbye to the remaining crew on the station.
Coverage continues at 4:45 p.m. for the actual undocking, then returns at 2:15 a.m. Thursday for the descent, and finally at 5:45 a.m. for the post-splashdown news conference. You can watch all of this on NASA Plus, Amazon Prime, or NASA's YouTube channel.
As we discussed yesterday, this is the first medical evacuation in ISS history. The crew was originally scheduled to stay until after Crew 12 arrived in mid-February, but an undisclosed medical condition affecting one of the 4 crew members prompted NASA to bring them home early.
After Crew 11 leaves, Expedition 74 will be commanded by Roscosmos cosmonaut Sergei Kudz-Furchkov, leading flight engineers Sergei Mikhaev and NASA's Chris Williams. That's a skeleton crew of just 3 people running the entire station.
Yesterday, Kudz-Furchkov and Mikhaev participated in a study assessing how crews make decisions and work together in space, which is especially relevant given they'll be operating with a reduced crew for a while.
NASA is still evaluating whether they can move up the Crew 12 launch date to replenish the station crew sooner than originally planned.
Now, let's talk about Mars, Anna. There's exciting new evidence that an ancient ocean once covered half the planet.
This is really fascinating research, Avery. A team led by Ignatius Argadestia, a PhD student at the University of Bern, has identified features in Mars's Valles Marineris that look remarkably similar to river deltas here on Earth.
Valles Marineris is that massive canyon system on Mars, right? The largest in the solar system?
Exactly. Along with Olympus Mons, it's one of Mars's most defining features. This research focused specifically on the southeast part of a subcanyon called Capratus Chasma.
The researchers used images from multiple orbital cameras, CTX and HiRISE on NASA's Mars Reconnaissance Orbiter and CASSIS on the ESA/Roscosmos Trace Gas Orbiter. They also worked with digital elevation models to examine what they call scarp-fronted deposits.
These scarp-fronted deposits, or SFDs, are fan-shaped sediment deposits that form where a river empties into a body of standing water. The team identified 3 of these features in Capratus Chasma, and they're almost identical to river deltas we see on Earth.
Professor Fritz Schlunjugger put it really clearly. He said, the structures that we were able to identify in the images are clearly the mouth of a river into an ocean.
What's particularly compelling is that all 3 SFDs are at the same elevation. That suggests they were all deposited at the same water level, essentially marking an ancient coastline.
The researchers believe these deposits were formed sometime between the late Hesperian period and the early Amazonian period. That's roughly between 3.7 billion and 3 billion years ago.
Reed author Argadestia said something interesting in the press release. He said, when measuring and mapping the Martian images, I was able to recognize mountains and valleys that resemble a mountainous landscape on Earth. However, I was particularly impressed with the deltas that I discovered at the edge of one of the mountains.
Previous research had suggested Mars had a large ocean, but this study provides much more concrete evidence. Schlunjugger noted that earlier claims were based on less precise data and sometimes indirect arguments.
But their reconstruction of the sea level is based on clear evidence of an actual coastline, thanks to these high-resolution images. The paleo shoreline they identified extends from Valles Marineris all the way to the northern lowlands.
Argadestia summed it up nicely. With our study, we were able to provide evidence for the deepest and largest former ocean on Mars to date, an ocean that stretched across the northern hemisphere of the planet.
This has huge implications for Mars's past habitability, as the authors write. Their findings will impact research on the evidence for potential life on Mars, since this represents a period when Mars had the highest water availability.
It's amazing to think that billions of years ago, Mars might have looked very different from the cold, dry desert we see today.
Speaking of things changing, Avery, let's talk about a fascinating new study on how spaceflight literally changes astronauts' brains.
This is wild, Anna. A team led by Rachel Seidler at MIT took MRI scans of 26 astronauts and 24 non-astronaut participants, and they found that spaceflight causes astronauts' brains to shift position inside their skull.
The study was published just yesterday. The researchers found a consistent pattern of the brain shifting backward and upward and rotating upward after time in microgravity. And here's the kicker. Some of these positional changes were still detectable months after astronauts returned to Earth.
Instead of looking at the brain as one whole unit, they divided it into 130 separate regions and examined each one individually. This regional analysis showed many areas with significant displacement across two spatial axes.
The dataset included astronauts with different mission lengths, roughly 2 weeks, 6 months, and 1 year. They found significant positional shifts across large portions of the brain, with some displacements measured as high as 2.52 millimeters in subjects with the most time in space.
To put that in perspective, that's about 1/10 of an inch. It might not sound like much, but when we're talking about the brain inside your skull, that's actually quite significant.
The researchers also compared astronauts with people who participated in a long-duration head-down tilt bed rest experiment, which is used to simulate some effects of microgravity on Earth.
And they found some interesting differences. Astronauts showed stronger upward movement, while the bed rest participants showed stronger backward movement. Only some of the brain shape changes observed after spaceflight appeared in the bed rest group.
This tells us that head-down bed rest, while useful, doesn't perfectly replicate what happens to the brain in actual microgravity. There are unique effects that only real spaceflight produces.
One of the most important findings was the connection to balance problems. The study found that displacement affecting sensory-related brain regions correlated with larger declines in astronauts' balance after spaceflight.
Right. We know that when astronauts return from space, they often experience balance issues because their inner ear's sense of direction isn't immediately restored. This study helps explain why that happens.
And while astronauts normally find their footing within a week or so, the physical shifts in their brains persisted for up to 6 months post-spaceflight. That's quite remarkable.
The authors note that this underscores the long-lasting effects of spaceflight on neuroanatomy. They recommend future studies with larger astronaut crews on a broad range of mission lengths to better understand how quickly these shifts begin and how they evolve.
This research is crucial as we plan longer missions to the Moon and eventually to Mars. Understanding how extended spaceflight affects the brain will help us better prepare astronauts and develop countermeasures.
Avery, let's shift gears and talk about a really exciting development in space telescope technology. There's a new privately funded observatory called Lazuli that could change how we build flagship-class telescopes.
This is fascinating, Anna. The Lazuli Space Observatory is being funded by Eric Schmidt, the former CEO of Google, and his wife Wendy through their philanthropic organization Schmidt Sciences. We're talking about a $500 million investment.
The whole premise is applying the new space philosophy to space telescopes. You know, that Silicon Valley mindset of move fast and don't break things. The idea is to prove that you don't need decades and billions of dollars to build a flagship-level space observatory.
Right. Compare this to the James Webb Space Telescope, which costs $10 billion, or the upcoming Nancy Grace Roman Space Telescope, which is on track for $3 billion. These huge costs come from using completely de-risked flight-proven technology to ensure taxpayer dollars don't literally go up in flames.
But Schmidt has a $36 billion fortune. So even if Lazuli fails, he can afford the loss. And that's kind of the point. This is an experiment to see if the approach even works for expensive flagship-level observatories.
To keep costs down, up to 80% of the telescope will use off-the-shelf components, and operating under Schmidt Sciences alleviates a lot of the bureaucratic and political decision-making that inevitably delays government-funded programs.
So where does Lazuli fit in the bigger picture? Webb is obviously already operational, sending back spectacular images. Roman is next, scheduled to launch in May 2027, but both have weaknesses when tracking transient phenomena.
Exactly. Events like kilonovae or gravitational wave-producing black hole mergers happen on timescales of hours, not days. They require almost immediate response from observatories to catch them before they end.
And Webb just can't slew, that's the term for rotating to a new target, fast enough. It captures extremely high-resolution images, but it takes too long to get into position.
On the other hand, Roman is a survey telescope that looks at white swaths of sky, but doesn't have the resolution to examine individual systems like Lazuli will.
So Lazuli's sweet spot is target of opportunity tracking. It's designed to slew within an hour and a half to observe short-lived events. It'll work in concert with ground-based observatories like LIGO, the gravitational wave detector.
But it has the advantage of being in space, so no cloud cover or daylight to worry about. Lazuli will also have a wild field context camera with 23 separate CMOS sensors, kind of like Roman, to detect things like exoplanet transits.
And here's something really cool. It should be able to directly image exoplanets using a vector vortex coronagraph, along with deformable mirrors to suppress starlight by up to 10 million times.
This same technology is planned for NASA's Habitable Worlds Observatory, which won't launch for decades. So Lazuli will actually serve as a technology demonstration platform well before the taxpayer-funded mission.
Perhaps the most impressive aspect is the timeline. Schmidt Sciences is planning a 3 to 5 year development cycle for this massive space observatory. That's exponentially faster than any comparable government-led system.
Though, to be fair, new space leaders do have a tendency to underestimate timelines. Even if it takes twice as long, though we'd still get another flagship-level observatory within a decade.
And here's something amusing. If Schmidt just leaves his remaining $36 billion in an S&P 500 index fund, he'd make back around 40 times what the entire project cost over a 5-year period. So financially, this is barely a blip for him.
Either we get an amazing new space telescope, or we get a $500 million lesson in what can go wrong when applying speed to large-scale astrophysics projects. Either way, the scientific community learned something valuable.
For our final story today, Avery, scientists may have finally solved a mystery that's puzzled them for over 60 years. Why does the moon look so different on its near and far sides?
This is based on analysis of dust collected from the lunar far side by China's Chang'e 6 mission, which returned the first ever samples from the moon's hidden hemisphere in 2024.
The material came from the South Pole Aitken Basin, which is believed to be the site of the largest impact in the solar system. This colossal crater spans nearly a quarter of the lunar surface.
A team led by Heng-Si Tan from the Chinese Academy of Sciences conducted isotopic analysis of potassium and iron found in the far side dust and compared it with samples from the moon's near side collected during the Apollo missions and by China's Chang'e 5 spacecraft.
The results showed a significant difference. Near-side samples contained more light isotopes, while the far-side material was richer in heavier isotopes, particularly of potassium.
This type of isotopic separation couldn't be explained by normal volcanic activity. Instead, the researchers suggest the South Pole Aitken impactor generated such extreme heat that lighter isotopes were vaporized and lost, leaving behind a heavier chemical fingerprint.
The researchers wrote, "This feature most likely resulted from potassium evaporation caused by the South Pole Aitken Basin forming impactor, demonstrating the profound influence of this event on the moon's deep interior."
What's particularly interesting is that the study suggests the impact may have punched through the crust and into the mantle, permanently changing the moon's inner composition.
The sample analysis revealed that potassium isotopes on the far side appear to originate from a mantle source distinct from that of the near side. This implies widespread internal melting and chemical redistribution.
The team even proposes that the impact might have triggered hemisphere-wide mantle convection, a process that could reshape a planet's crust and inner layers over time.
As they noted in their study, this finding also implies that large-scale impacts are key drivers in shaping mantle and crustal compositions.
So, planetary impacts leave far more than just visible craters. They can set off long-lasting internal transformations that remain detectable billions of years later.
Heng-Si Tian summed it up nicely. With our study, we were able to provide evidence for the deepest and largest former ocean on Mars to date. Wait, that's the wrong quote.
Wrong planet, Anna.
Oh my goodness, let me get that right. Pian said, with the Chang A6 samples, scientists now have their first hard evidence from the moon's far side, an area once entirely out of reach.
This discovery is particularly timely as multiple nations gear up for lunar exploration missions, including NASA's Artemis program and China's continuing Chang'e missions.
Understanding the moon's geological history and internal structure will be crucial as we plan to establish permanent bases there. Each new sample and discovery helps us piece together the story of how our nearest celestial neighbor formed and evolved.
Well, that brings us to the end of today's episode of Astronomy Daily. What an incredible day of space news.
From nuclear reactors on the moon and the Crew 11 undocking tomorrow to ancient Martian oceans and shifting astronaut brains, plus a privately funded space telescope and solving the moon's two-faced mystery, we've covered a lot of ground today.
If you enjoyed today's episode, please subscribe to Astronomy Daily wherever you get your podcasts, and don't forget to leave us a review. It really helps other space enthusiasts discover the show.
You can find us on social media and at our website for more space news and updates. On the socials, search for Astro Daily Pod, and our website can be found at astronomydaily.io. Thanks so much for listening, everyone.
Until next time, keep looking up.
Clear skies.
Astronomy.